now here our sample problem. Okay. So we have here an unbalanced circuit below. So we're asked to find the line currents, the total complex power absorbed by the load, and the complex power absorbed by the source. So let's first go with this part. Okay. So let's first solve the line currents. So actually, if you have an unbalanced circuit or a balanced circuit, okay. So as what I've said a while ago, so we're going to solve that using mesh analysis. Okay. So we have here two mesh currents. So we have here I1 and I2. Okay. So we're going to have two loops here. Okay. Then we're going to loop and then create we're going to create two equations out of this. Okay. So for the first equation, so negative, positive, so that is 120. Angle verb 0. So that could be the other way around. If you're comfortable with the counterclockwise manner, that's okay. So for my case, I'm comfortable with the clockwise manner. Okay, so 120 angle verb 0, so positive. It will be attracted to negative and then positive. Okay. So therefore, we're going to have here positive and then we have there I1. So positive, okay, negative, positive. Okay, so we have here positive J5. Okay, so that would be plus I1 J5. So positive, negative, positive, okay, and then 10. So that would be plus I1 and 10 ohms. And we have here, okay, so opposing voltage, so that would be negative. So that would be minus 120, angle of negative 120. Okay. So let's consider the flow of I2. As you can see, it opposes the flow. So kung siya pupunta dito, okay, kung mapapansin nyo siya dito, eto, pakontra. Meaning to say, kung yung I1 natin is nag-add up, si I2 ay mag-subtract. So that would be minus 1. So that would be minus I2 times 10 ohms. So combining similar terms, okay? So we have here I1 multiplied by 10 plus J5 minus I2 multiplied by 10. So 120 angle verb 0 and 120 angle verb negative 120. So that's equal to negative 120 square root of 3 angle bar of 30. So transposing that to the other side, okay. Or if you're going to fix this equation, okay, so that would be 120 square root of 3, okay. So this equation is 0, angle bar of 30 degrees. So we have now concluded or created our first equation. So that's our equation number 1. Okay, let's consider the mesh current in the second loop. So the loop on the bottom part of the circuit. Okay. So from here, paganon siya, paganon, paganon. So that would be, okay, so positive. So we have here 120, angle bar of negative 120. Okay, so I2 rise. So therefore, this will be negative positive. Okay, so that would be plus I2, okay, times 10. So negative J10. So this will be minus, okay, I2 J10. And then, that will be subtraction. So that will be minus 120, angle bar of 120. And then let's consider the opposing current in this loop. Okay, so since it's opposing, that would be subtraction. So that would give us minus I1, okay, times 10. Equals to 0. So let's combine similar terms. So combining this and this, okay, so that would give us, okay, so that would give us 120 square root of 3, angle bar of negative 90 degrees. Okay. So let's factor out I2 here, and then let's consider I1 here. So we have here negative I1 times 10, okay, and then factoring out I2, so that will be plus I2 quantity 10 minus J10. So we have now our second equation. So how do we solve this? By using two equations and two unknowns, and if you're finished with your advanced mathematical methods in engineering in undergraduate years, you can solve that using determinants. So it's the most efficient way to solve that. Why determinants? Because as you can see, we have here a complex number. So that by using determinants, you'll have here a matrix. So 10 plus J5 and negative 10 for our first equation. And then we have here negative 10, 10 minus J10. So for the constant terms, that would be this and this. So that would be this and this. Okay. So let me cut the video short and then actually. So upon using these determinants, okay, so we can solve our values of our determinants such that our D would then be equal to 70.71 angle bar of negative 45 degrees. You see that? Our D sub x or our D sub I1, sorry for this. Solve this right away and then let's just calculate to solve this. Actually, this is something that makes this, the solving for this circuit, a bit longer. Kaya mahaba siya ng mga 35 to 40 minutes or at least 30 to 45 minutes ang solving kasi dito sa may determinant part. Yan ang nagpapahaba. So, DI1 would then be equal to 4015 angle bar of negative 45. And our DI2 would then be equal to 3023.4 angle bar of negative 20.1. So those are, yun yung mga natin, mga determinant values natin. So paano sinusolve yun? Remember, pag solve ng determinants, piniplace lang natin sa may missing. Say for example, kay I1. Itong I1 yung column ng I1, okay, papalitan lang natin siya nung constant ng nasa may equation niya. Ito. Pag DI2, ito, papalitan mo lang siya nito. Okay. Yung 120 square root of yung angle of negative 90. Okay. So ito, papalitan mo lang lahat ito nung constant terms na ito. So same process na dalawa. And then how will we find our I1 and I2? So I1 can be found by using the formula DI1 over D. Okay. So for DI1 over D, pag divide mo yung dalawang yan, you will obtain the value of our I1 as 56.78. And then our I2 would then be equal to, okay, so I2 is DI2 over D, so that is equal to 42.75 angle bar of 24.9. So may konting discrepancy lang sa value, okay, so sa pagkakaroon of lang yun. So don't worry, so isa lang sinakasir naman yan, and may-share ko naman kung anong problema dyan. So meron tayong I1 and I2, pero hindi pa yan yung mismong line current na hinahanap natin. So paano natin kukunin yung line current niyan? So that would be our next problem. Okay, so let me cut this video short and let's proceed with solving finally the line currents of this problem.